We'll proceed in pseudo multivariate calculus and we will see area vector. Mind blowing area vector. We are in phase of calculating area vector through the traditional way that we know. What is the traditional way to calculate the area vector? The traditional way to calculate the area vector is like if, oh, okay, what is traditional way to calculate area vector? What is traditional way to calculate flux? If there is a liquid that is flowing and it is passing the surface, then what is the volume of the liquid that is coming out of the surface? That is called flux. Okay, or there is a point through which liquid is gushing out. There is a point through which liquid is gushing. Liquid means not only water and solution. Electromagnetic radiation can also be considered as liquid only. This is what I mean. So when there is a point source, there is a there is a point source. From point source, liquid is emanating all around. From point source, liquid is emanating all around. If that is the case, then if I have a surface around it, then what is the volume of the liquid that is coming out? This can also be a question. Okay, if i have if I have a point, if I have a point, from point all around liquid is gushing out, then I make a closed region, or I make a surface, closed surface, then how much is the liquid that is gushing out from the surface? What I'm trying to say, okay, now consider inside the center of this, consider this is a sphere. Center of this sphere, there is a point through which liquid is gushing out in omni direction all around. How much is the liquid that is coming out of the surface? Volume of the liquid coming out of the surface per second. Volume is meter per cube. Meter cube of the volume of the liquid that is coming out of the surface per second. If if radius is bigger, then more liquid will come out of the surface. If surface is near, means radius is small, then certainly less liquid will come out of the surface. Then someone needs the velocity formula. What is the velocity formula of the point source? That how much is velocity of the liquid that is gushing out from the point source, and then dot product with the surface area. This is where the pseudo mathematics clicks in. Now, if someone asks anyone that there is a point, consider there is a point. From point electromagnetic radiation is gushing out from all directions, or point a liquid is gushing out from all directions. I place a closed surface around it. How much is the volume of the liquid that is gushing out of the closed surface? That is under question mark. Okay, then no one will understand what you are asking. How much liquid will come in? Then this is called pseudo multivariate calculus. Pseudo multivariate calculus means think in a simple way. Think in a simple way. Consider there is a flow of liquid that is going on. Consider there is a very big pipe, or a liquid is flowing in a kind of a in a in a pipe manner. Okay, someone dig out a pipe kind of a deep pipe kind of shape in earth, on the earth, or someone make a kind of water pass through, or some kind of channel. This is what I can say. Some channel, someone has cemented out one channel. On the in the channel or canal, liquid is flowing. Now I am putting one up. I am putting one rectangle. Consider this is a rectangle and this is a canal, and what liquid is flowing. If I put my this rectangular region here, how much I feel that from my hand, this hand, how much is the volume of liquid that is passing through my hand? That is the question. How much is the volume of the liquid that is passing through my hand? That is passing through my hand. This is the question. Okay, that is velocity of the liquid into surface area. That much is the volume of liquid that is coming out. Someone can find the velocity of the river in that fashion, or velocity of a canal. Okay, okay, how it is? It is quite simple. We take a rectangular region and place rectangular region in the liquid, and other side of back side of the rectangular region place a balloon kind of thing, where whatever rectangular region it has a only the only the kind of its boundary is there, thin boundary is there of the rectangular region, and inside it completely hole. From the hole there is a balloon here, and liquid is coming, passing through this hole and going inside the balloon. Now measure for 1 second or something like that and take it out. See what how much is the liquid that is amassed in the balloon, and that is the volume that passed through the surface in that many times. If someone is measuring for 60 seconds, that whatever volume is liquid is collected in the balloon or in the bag by 60, that is the flux of it. Okay, if that is the flux, I know the surface area. Flux by surface area will give the velocity of the liquid. Someone can measure velocity of the liquid in this fashion also. The question is arising that what is the flux that is coming out? Velocity of the liquid into surface area, or velocity of the liquid dot product with the surface area. If liquid is passing like this, and surface area vector is always perpendicular to the surface. So this is surface area vector. Okay, so if I consider this side, then this is the surface area vector perpendicular to it. If I consider this side, this is the surface area vector perpendicular to the surface. If the surface area vector and liquid direction, they are in same direction, then it will be considered as just multiplication. Otherwise, dot product. So velocity vector dot product, velocity vector dot product, the surface area vector, the velocity vector dot product, the surface area vector is the net flux coming out of the surface. If that is the case, if that is the case, then what is surface area vector? Velocity vector. If surface area vector, this is surface area vector, and this is if they are in same direction, all right, but surface area can be like this, surface area can be like this when it is in same direction, surface area can be like this, surface area can be, this is surface area vector. Now it is exactly perpendicular to the liquid, then dot product will be 0, means nothing is going inside this. Okay, in that way, this is the simplest case. What we are talking, that consider there is a liquid source inside it at the origin. There is a liquid source and liquid gushing out of it, all direction. How much is liquid passing through this sphere surface? That is the simplest case. Liquid velocity, liquid velocity into surface area is the net flux. Then liquid velocity dot product, liquid velocity vector dot product with the surface vector area, where surface area vector is the net flux. Now question is arising, how we calculate surface area vector? How we calculate surface area vector? Velocity vector will be provided that it is 2i plus 3j plus 4k, 2i plus 3j plus 4k. If that is the case, 2i plus 3j plus 4k, the magnitude of this liquid velocity, if this is velocity vector, then velocity vector's magnitude is 3 square plus 4 square plus 5 square square root, 3i plus 4j plus 5k. Okay, that is the velocity, and direction is like this only. Dot product with the area vector. What is the area vector? Now area vector we have computed it. Area vector, there are two ways. One way to calculate the area vector is whatever written in the book. Another way to calculate area vector is through the pseudo multivariate. Whatever we are calculating right now, that is itself a pseudo mathematics, because we are not calculating the actual flux that will come out of this sphere. Okay, we are calculating the flux for any simple rectangle and a velocity in one direction. If that is the case, then area vector again can be through two ways. One is conventional way. What is conventional way? Conventional way is if I take any point on the surface of a sphere and from center of it, the center of this sphere is the origin. From center of the sphere, that is origin to point P, if I draw a position vector, then derivative of position vector. What is position vector? Position vector is representing area. Position vector can represent a line also. Position vector can represent an area also. Position vector can represent a volume also. Position vector of what? Position vector of an area. If I have position vector of an area, if I derive the position vector of area, if I write, what is your position vector of the area? That is P, capital P, and on top of it arrow mark. That is called position vector of an area. If I write D, small d and capital P on top of it arrow mark, this is derivative of position vector. Derivative of position vector. If position vector represent a line, a curve, okay, consider, consider this is origin, and this is a line. If that is the case, consider this is origin and this is the line. Origin is fixed and every point on the line, keeping this point fixed, every point of the line, this is moving like this. But this is fixed. This is called position vector of this line. Line has x and y that is varying. In that sense, or x, y, z. Then this is fixed, that is 0, 0, 0. This is called position vector along the line. If I have a position vector that is xi plus yj plus zk, where this point is x, y, z, then dp, derivative of this position vector, will be tangent vector at this point. That is along the line only. So derivative of position vector will always be a same thing. If I vary the position, if I keep varying the position vector, keep varying the position vector, and since it is a straight line, then tangent will be everywhere same. D of position vector will give the equation, vector equation of this line actually. Okay, can someone try D of, actually even I don't know. D, what is position vector? That is xi plus yj. D of position vector, that is dxi plus dyj. That is the position vector. Let's try. Who stops us trying it? Let's take a line equation that is y minus x equal to 2. Y minus x equal to 2. I believe it is all right. Y minus x, I'm sorry. Y plus x equal to 2. Y plus x equal to 2. Y equal to 2 minus x. If that is the case, when y is 0, then x equal to 2. When x is 0, y equal to 2. I have a line like this. This is x-axis, this is y-axis. I have a line like this where interception on the x-axis is 2, 0 and interception on y-axis is 0, 2. This is the line 2, 0, 0, 2. If that is the case, then equation of this line is x plus y equal to 2. X plus y equal to 2. Okay, if that is the case, then y equal to 2 minus x. Okay, now when x is 0, that is along y-axis, y is 2. When y is 0 along x-axis, x is 2. Now, what is the vector representation of this line? If this, I'm sorry, this is x-axis, this is y-axis, and line I am talking about, this is this line. That is y equal to 2 minus x. Okay, if that is the case, 2 minus x. Now, this is the, consider this is the position vector along the line. Position vector is xi plus yj, because xy is kind of xy is generic point. D of position vector is the, if this is the line and this is the position vector, D of this position vector is tangent at this line, that is the along the line only, if it is a straight line. Then what is d of position vector? D of position vector is d of x, d of xi plus yj, dxi dx plus dy. D of xi plus yj means dx plus dy. Oh, I'm sorry. D of in bracket xi plus yj is same as dxi plus dyj. Makes sense? Dx is all right. Dxi plus dyj. Okay, this is the vector representation. This is the vector representation. Okay, in that sense, if I take out d, what is y? Y equal to 2 minus x. Y equal to 2 minus x. If that is the case, dy will be minus. I'm sorry. Let's proceed. Okay, y equal to 2 minus x. Dy equal to minus dx. Dy equal to minus dx. Then it will become dxi plus dyj, that is minus dx. It will become 0. This is not we want. We want the tangential vector along the kind of position vector. Okay, I'll try again. Let's take out dx from here. It becomes I plus dy by dxj, bracket close into dx. Now it will be easier. Okay, I plus dy by dxj. I'm sorry. It is not, we are not making wrong thing. Anyway, we'll try again. We are saying that position vector, if I calculate derivative of position vector, it will give the tangential line. That is the line through for which we are trying to get the vector notation, vector representation. Position vector is xi plus yj, d of xi plus yj, d of xi plus yj will be xi plus yj d, dxi plus dyj. Y is 2 minus x, then dy will be minus dx. It becomes dxi minus dxj. Both are not same. Dxi minus dxj. If I take out dx from here, it becomes I minus j. I minus j into dx. Okay, x is from 0 to 2. X is 0 to 2. That will be 0 to 2. X will be 0 to 2 means it will be 2. 2i minus 2j is the vector representation of this line, knowingly, unknowingly. X, y equal to 2 minus, these are trillion dollar explanation. Means it is not available in any of the book. Anyone can try. If this is the case, then vector representation of a line y equal to 2 minus x is 2i minus 2j. 2i minus 2j. Okay, this proves that if I have a position vector and if I calculate derivative of position vector, it gives the tangential vector at that point. Okay, in that way, if I have a position vector here, position vector P on the surface, and if I say if there is a point P here and from center of it, if I draw a line, that is a position vector. If I calculate derivative of this position vector, then it will give me the surface vector. Though surface vector is not along the surface, the actual vector direction is not along the surface, but we mean it, we want surface. If we want surface, then whatever the position vector is, calculate the derivative of the position vector and you get the surface vector, surface area vector. In that sense, the net flux will be velocity vector dot product d of position vector, where position vector represents the surface area. Now, if I want to proceed, then P is dx, P is xi plus yj plus zk, dxi plus dyj plus dzk. That is the surface area. That is the actually surface area vector. But this is not going to give anything to us. So instead of writing dp, I am writing a d of p by dxy plane into dxy plane. Now, it's the same thing. I can multiply with the same thing. I can divide with the same thing. D of position vector by d of xy plane into d of xy plane. What is dp by dxy? This is traditional way I am talking. I am not talking about our multivariate case, multivariable case. We have talked about it. Now d of position vector by d of xy plane. what it talks about? It talks about that if I have a it talks about if I have a xy plane and I have a 3D surface here. If I have a xy plane, I have a 3D surface here. If there is a xy plane and there is a 3D surface here, if that is the case, then what is dp by dxy? dp by dxy means if I make, please mind it, what I'm saying, please mind it. What need to be minded is in this xy plane, consider any point here. This is origin blue color. Consider any point here x comma y. For this x comma y, there is a point on the surface here called P. I have talked about this in the past video. These explanations are not available in any of the book, any material. Now, if I take any point x comma y here, hope, I'm not that strong. So if I take any point x comma y here, if I take any point x comma y here, this point on x comma y here, it will go up and it will hit a point P on this surface. It will hit a point P on this surface. Consider this is point P. So if surface is like this, consider this is point. This is sphere. It is centered at the origin. Means half of this sphere. This is a sphere centered at the origin. Means half of the sphere is above xy plane and half of the sphere is below xy plane. This is the top hemisphere. This is the bottom hemisphere. If that is the case, then it is like this half of the way. Half of it is above the xy plane and half of it is below xy plane. This is a sphere. If that is the case, then if I take any point x comma y here and from there I draw a line, consider it is going to hit here. Now at point x comma y, I proceed along x-axis delta x. I have another point called P. That point is x comma y on xy plane. I have another point called x plus delta x comma y. Similarly, if I proceed in y direction, I have another point called x comma y plus delta y. Means I have 4 points now. One point is x comma y on xy plane. Another point is x plus delta x comma y. Another point is x comma y plus delta y. And fourth point is x plus delta x comma y plus delta y. Similarly, those points will go and hit on the surface. 4 points here also. One point is P that corresponds to x comma y comma z. Z is function over x and y. Another point is P1 that corresponds to x plus delta x comma y comma function over x plus delta x comma y. Another point is P2 that is x comma y plus delta y comma function over x comma y plus delta y. And another point is P3 that is the corner one, that is x plus delta x comma y plus delta y comma function over x plus delta x comma y plus delta y. 4 points. Now the question is arising here, if at any point x comma y on the surface, at any point x comma y on the surface, if I make a small area change, that is delta x and delta y on the surface, of the sphere, how much area change I see? Makes sense, right? On the xy plane, I had a point x comma y. From there, I went along x-axis, I went along y-axis. It makes a rectangle. That is delta x, delta y. If I go top, then I have a point called x comma y comma z. From there, one point will go towards x plus delta x comma y comma function over x plus delta x comma y. And then it will go to another point on the surface. This is the first point, that is P, x comma y comma z. It will go one point here, that is x plus delta x comma y comma function over x plus delta x comma y. It will come back to P again and then it will go in other direction. That is x comma y plus delta y comma function over x comma y plus delta y. Now, then I'll go to fourth point. Then I'll go to fourth point. Fourth point is, that is P3. P1, P2, P3. That is x plus delta x, comma y plus delta y, comma function over x plus delta x, comma y plus delta y. what is the surface area that I am seeing, that is between P1, P2, P3. If I see the surface area on the XY plane, that is between x comma y and another, that is delta x into delta y. Means if I make delta x delta y change on xy plane, how much surface area change I see in the on the 3D surface, that is dp by dxy plane. D of xy plane means in xy plane, if I make 1 unit of area change, then how many unit of area change as a position vector I see on the surface, that is called d of p by d of xy plane. Makes sense? This is typical, this is primitive differential calculus per unit change. Right now we have made delta x delta y area change in xy plane. With that we are getting delta, with that how much area change we are getting on the surface. If I divide this, we will get per unit change in the xy plane how much that we are getting. With delta x delta y on the surface we are getting. Now from the P to P1 I'll draw one vector, and P to P2 I'll draw one vector and do the cross product of these two vectors. Then I'll see the surface area on this surface. I can do cross product here also, delta xi cross delta yj. That the area I am seeing on the xy plane is delta xi cross delta yj, that is delta x delta y. Okay, but there if I do cross product, one point is x plus delta x comma y comma fx plus delta x comma y, and one point is x comma y comma fx comma y, function over x comma y. If I subtract, then I get p1 vector, and if I subtract in a similar manner, I get p2 vector. So net dp by dxy plane becomes dpp1 cross dp1p cross dp2p divided by delta x delta y, or I can segregate it as d, or I can change it as, I'm sorry, d of position vector by d of xy plane, means delta x delta y. If that is the area change on xy plane, how much we are getting there, that is p1p vector cross product p2p vector divided by delta x delta y. Now d is gone, d is gone. Now it becomes now p1p divided by delta x cross p2p divided by delta y. Okay, what is P1P and what is P2P? P1P is x plus delta x minus xi plus y minus yj plus fx plus delta x comma y minus fx comma yk divided by delta x cross product with now f cross product with x minus xi plus y plus delta y minus yj plus plus fx plus delta x, I'm sorry, plus fx comma y plus delta y minus fxy k divided by delta y. It will become now delta xi plus yj component will go away, delta xi plus fx plus delta x comma y minus fxyk divided by delta x. It will become I plus, okay, this will become I plus fx plus delta x comma y minus fxyk divided by delta x. This is exactly as dz by dx. dfxy by dfxy by dx, fx plus delta f is a function, f small f and then bracket open, x plus delta x comma y bracket close, fx plus delta x comma y minus fxy divided by delta x. This is exactly dfxy by dx or dz by dx. So first term resolved into I plus dz by dxk. This is exactly dp by dx. If p is xi plus yj plus zk, then it is exactly dp by dx. Cross product dp by dy. Someone can try there. Okay, means dp by dxy plane is dp by dx cross dp by dy. This expression is not available in any of the book. The position vector of a surface area d of position vector by dxy plane is dp by dx cross dp by dy into bracket close into dxy plane. That will dxy plane will be delta x delta y dx dy. This is area vector. Okay, if someone find it out, I plus dz by dxk bracket close cross product with j plus dz by dy k into dy dx, it will come to whatever we started with our pseudo multivariate class. Strongly recommended, and please watch our previous 2 to 3 videos. That is strongly recommended. Anyway, this is the scenario for the traditional way of calculating the surface area vector. That is d of surface area position vector is the surface area vector. That is same as dp by dxy plane into dxy plane. That is same as dp by dx cross dp by dy into dx dy. And then you will get minus dz by dx I minus dz by dyj plus k bracket close into dx dy. Okay, now question is arising that we are trying to find surface area of a sphere. Okay, someone can find. Can someone try in different coordinate system? Can I try this in a spherical coordinate system? Right now we are talking about z, x, y. Can I find through a spherical coordinate system through both way? One is traditional way, that is d of p. What is surface area? D of p. What is the volume? Then d of p. What is your line length? D. What is your line vector? D of P. What is surface area? D of P. P represent position vector for the line. P represent point on the surface area. P represent point on the volume. Depend upon P represent what. So dP by dxy plane into dxy plane, or dP by dx into dx, or dP by dxyz into dxyz. Depends upon what you want. These are not there in any of the books. This is the way we proceed. A question is arising that if we are so sure about that this is the way that traditional calculus works, what is our pseudo multivariate calculus? Pseudo multivariate calculus is that if I take any point P here, I make a cut here, and then I make a cut here. If I make a cut here, it will make a circular line in xz plane. If I make a cut there in yz plane, it will make a circular line in yz plane. Circular line is a curved line for which in xz plane, as per our length vector, it will be I plus dz by dxk bracket close into dx, and curve vector for a line in yz plane will be j plus dz by dyk into dy. Straight form. Do cross product of this curve line and cross product of with cross product means, if you take cross product, how we started with the pseudo multivariate is, I'm trying to find area vector here. Rather than finding this difficult area vector, we started with the area vector of a rectangle. An area vector of a rectangle is this vector cross product with this vector. This vector and this vector, if I take cross product, it will give area vector. This vector is A vector and this vector is B vector. If I do cross product of A and B, A vector cross B vector will give the area vector. Okay, what about if your area is like this? Then this is, earlier this was a straight line, A vector become a curved line. Still, with our fundamental, still we can represent a curved line through vector. Earlier this A vector was xi plus yj. Now this curve vector will be I plus dy by dxj bracket close into dx. Please watch our previous video. So curve line vector is same as xi plus yj, but I take out x or I take out y. So this A vector, A vector, if this vector is along x-axis, then I take x out, and if this vector is along y-axis, I take y out. So more or less, this falls in xy plane. Okay. Similarly, if I'm trying to find surface area of this, then it is a curve shape. then this is A vector and this is B vector. To find the A vector and B vector here, I make a cut in XZ plane and I make a cut in YZ plane. Since those are orthogonal to each other, this is all right. I can make cut in any of the plane. There is nothing like that. I can make a cut in XZ plane, I make a cut in YZ plane because they are orthogonal to each other. Then it will give, cutting these two in XZ plane and YZ plane will give me a curve. Okay, circular curve. Like this is circular curve in XZ plane, this is circular curve in YZ plane. Now this curve equation, this curve line in vector form, if I calculate in vector form, if please watch our previous video. So this will be the curve line. If I take this in vector form as a straight line, then if consider this is origin and this is a straight line, this is a straight line. I'm sorry, this is a straight line and this is a straight line. This is in XZ plane and this is in YZ plane. This is what we are doing. Now this straight line in XZ plane become a circular line. And this is in YZ plane, it become a circular line. Okay, in XZ plane, what is the vector representation of this? This is xi plus yj plus zk. Xi plus yj plus zk. If I take out x, then it is I plus dy by dx, j plus dz by dxk, bracket close into dx. dy by dx is 0 because along the in xz plane y is not changing. Similarly, in YZ plane, x is not changing if I change in y. There, in YZ plane, if I talk about the vector representation of a straight line, that is again xi plus yj plus zk. If I take out y, then dx by dyi plus j plus dz by dyk, bracket close into dy. dx by dy is 0 in that section, then there it will become as j plus dz by dy into dy. So more or less, if I'm trying to calculate the surface area of a sphere, this curved surface area, then it will be cross product of one curve and another curve. One curve and another curve. One curve line is in XZ plane and one curve line is in YZ plane. XZ plane curve line is I plus dz by dxk, bracket close into dx, and yz curve line is j plus dz by dyk into dy. It will come as I plus dz by dx cross product with j plus dz by dy into dx dy. It will be same as dp by dx cross dp by dy only. This validates our approach toward the pseudo length vector anyway. Now next question is arising that when we are trying to calculate the surface area vector of a sphere, everything we are trying in the Cartesian coordinate system. Take it as an assignment that can someone calculate the surface area vector in traditional way. What is traditional way? D of position vector. That is traditional way. What is our multivariate calculus? Cut in XZ plane, cut in YZ plane, and then do the cross product of two length vector, you get the area vector. But traditional way is D of position vector. Consider this position vector. If I try, someone can try in the, because dz by dx, what is the area vector? Minus dz by dx minus dz by dy plus k, bracket close, into dx dy. Z is the square root of a square minus x square minus y square. This is complex. Minus dz by dx, then minus dz by dy plus 1. Whatever comes, then I have to calculate magnitude of it, because if we are calculating the magnitude of the area. Otherwise, if I am calculating flux, then velocity vector, that is v1i plus v2j plus v3k, dot product with minus dz by dxi minus dz by dyj plus k dx dy. Whatever comes, then calculating the magnitude of it, and then doing the integration, the limit of x and y will give the actual flux. If I take out the velocity factor completely, or velocity is 1i plus 1j plus 1k, or I plus j plus k divided by a square root of 3. That will be unit vector, I believe. 1 square plus 1 square plus 1 square root by square root of 3. This is a unit vector. If I take like this, then dot product with minus dz, I'm sorry, velocity vector if I take I plus j plus k only. I plus j plus k. Hop, whatever it is, just leave it. Just leave the velocity vector. If I'm trying to calculate the surface area, then same way, whatever we got the surface area vector, calculate the magnitude of this, then integrate along x and y, putting limit of x and y. Okay, that is the surface area, but it will be difficult. Can someone try in a spherical coordinate system? Spherical coordinate system is z equal to spherical coordinate system has theta, phi, and r. Theta, phi, and r are three independent variables. Z is r cos phi, x is r sin phi cos theta, y is r sin phi sin theta, where phi is angle from vertical, theta is angle on xy plane, and radius is from center. Radius is growing. If that is the case, then dz by d theta. I'm sorry. If that is the case, then z can be substituted as r cos phi. X is r sin phi cos theta. R sin phi sin theta. What will be dz by dx, dz by dy, and plus k? It is complex. So if I start in a spherical coordinate system, I have to start from dp only. What is area vector? D of position vector. What is position vector? That is xi plus yj plus zk. What is xi plus yj plus zk? That is r sin phi cos theta I plus r sin phi sin theta j plus r cos phi k. D of that. D of that. Okay. If I proceed in this way, then how I will proceed calculating the area vector? This is through traditional way. D of position vector, where position vector is in a spherical coordinate system. Then how dp by what? Earlier we did dp by dxy plane into dxy plane. How? And then how we will proceed in the pseudo multivariate calculus, calculating the surface area vector through the surface area vector through the pseudo multivariate calculus. We will see. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.